Hi, welcome back. And today we're going to continue the part 2 of section 10.2 here. And for this sections here, we're going to talk about is the function transformations here. So if we know the basic function and how do we transform that without physically just choose the points. Okay, so the first ones here, we said, you can move up or move down here. So how do you move up or move down? So you add a number and then, or you minus the numbers, right? So when you minus numbers, so these ones here, you move up. And these ones here, you move down here. Okay? So like, if we says here, right? So for examples here, if, for these functions here, so I don't know what is the function here, but we say, okay, this is my f of x functions here, right? This is the green ones here. Okay, so if I said, okay, I want to define the, so I will say this is f of x plus 1. So what is this function doing here? That means the whole thing move up once here, right? So like in here, okay, so the way we do this is like, okay, the way we do that is, okay, so this one used to be at 4, so this point I move to where? I move to the 5 here, right? And then the 5 here, this point used to be at 0, so I move to where? I move to 1 here. Correct? And this points here used to be 0, so I move to 1 here also, right? And then this point is somewhere I move up 1, so it's something here. So now when you try to connect it, so that's what is the, my points here. So this is my new graphs here, right? So the here, okay, and then here, okay, and then the here. Oh, why I wanted to, okay, so now I can do here, here, and then this one's here. See here? So this is my what? This is my pink one. So the pink ones here, I go up. So the same way, if I go down, I can just minus the number. So like the reason why those transformation is pretty easy to do is because then you don't really need to graph by points anymore, right? So let's try to do one more here. So for examples here, I'm going to go like f of x minus 2 here. Then let's see what is the problem, what is the graph looks like. So like in here, this point going to go down at 0, right now going to do the negative 2s, right? This point used to be 1, 2, 1, 2, 3. So I go down 2, I go down here, right? I go down here. Then this ones here used to be 0, I go down 2 here. Then this ones here, I go down 2 here, right? Okay, so now let's try to graph it. So this one's here, so what happens here? So this will be my graph here, right? Okay, so here. Right, so that's what is my golden graphs looks like. That's what we talk about is moving up and down, right? So if you add something, you shift the whole your graph up. You minus something, you move the whole graph down. So the key part to do it, I think I did something. This one is not quite right here because I was not careful. Okay, so I need to redo that, redo that, redo that, redo that, redo that. Okay. All right, so first one's here. This point is okay. I got this one. this point is from here, I need to go down 2 units, so it's go down to here. That's right now, it's much better. Then this one is go down to here. And then this point right next to it is go down here, right? So now that's what the graph going to looks like, much better here. Right? So here's this way, and this way, and this way. So all these three graphs, they should parallel to each other, right? So it's kind of like the moving up and down here. Okay, so what is the shift, the right and the left here? So if you minus number, so basically what you do here is like you set the whatever inside here is equal to 0, then you solve for x, and then you shift it, right? So like in here, for example, here, okay? If I said f of 2, x minus 2 here, okay? So that means that I'm shifting to the right 2 units, right? So because if you set this equal to 2, you set x minus 2 equal to 0, so you will solve x equal to 2. So that's why you shift to the what? You shift to the right, the 2 units here, right? Okay, so now let's see, how do we do that? We still use the green. Green is my parents' functions, right? So I shift to the 2 units. So this point going to shift to here, 1, 2. This point going to shift to here. And this corner point going to shift to 1, 2. We're going to shift to here, right? And then this point going to shift to 2, 1, 2, going to shift to here. And this point going to shift to 2 is 1, 2, is something here. Okay, so now if you graph it, so you graph it now here. Okay, that's what will be the blue ones here, become a pretty kind of a pretty busy here, right? So but now if you want to reflecting over to the y-axis and the x-axis, so what is the reflecting to the x-axis? Is like this is reflecting. So this is the reflecting to the x-axis. That means you just flip over, and then this one's here is you reflecting to the y-axis here, okay? And you know those reflection will make your graph, because we're talking about the quadratic functions, right? So let's take a look here, right? So now, how do this help us? Let's go to the next page here. Back to our quadratic functions here. So first things here, we talk about the quadratic. I want to graph it. First things here, let's know what is, we call this the parent functions. So for the parent function, the f of x, we're going to talk about, this is x squared. So this, we call this the parent function. Because the same time when we talk about the quadratic, the inverse of quadratic is the square root. So in here, we're also going to talk about the square root functions. Now we're going to be able to graph both of them at the same time. So the parent function, what do we mean the parent function? That means it's nothing, just a pure x by itself, right? So this is a parent function. And so for the parent function for the quadratic, you know, for every time when you do it, you go get a, oops, this is not look too good, okay? So every time when you try to do it, you always have a few key points you can do, you know, you need to know. Okay, so the parent function for the quadratic. So in here, those are the key points will help you to do the transformations, right? So the key point here, first one is 0, 0. Okay, so that means when x equal to 0, y equal to 0. So it's this point. Then the next point is here is 1, 1. So when x equal to 1, y equal to 1, right? So the 1, 1, so here, 1, 1 is here. And we also have a negative 1, 1, right? Negative 1, 1. So it's this point. Okay, so this is 1, negative 1. So if you want, you can do another one. It's 2, 4, negative 2, 4. Then you will have plenty points to graph. So this is 1, 1, 2, 3, 4, right? So here, this is 2, 4. So 2, 4 is here. Negative 2, negative 2, 4 is here, right? So this is what is your parent function going to, oh, I cannot do very beautiful. Hopefully I can do very nice, but you know, it's very difficult to do the, oh, but anyway, so this is a quadratic, right? So here, and, I hate to draw like on the whiteboard. It's just very difficult, right? So remember, those are the key points. This will help us for the, you know, for the transformation. Okay, so what is the parent function for the root functions here? This one is pretty easy. So the here, okay. Then the key points here. First point is 0, 0. So when x equal to 0, I have zeros here. Okay, so the next point here is 1, 1. So that means when x equal to 1, y equal to 1 here, 1, 1. So this is the 1, 1 point. Then the next point here is 4, 2. All right, so 4 2s here, that means this is 1, 2, 3, 4, 1, 2. So 4, 2 is here. So after you have those few points, you'll be able to draw your parent function. So this will be your parent's functions here. Right? Of course, this is not, doesn't have a dip there. So the here, smooth, right? Okay. So this is your parent function. Let's see why this one is very helpful here, right? So let's take a look at some examples here. I'm starting with the easiest one. Okay, so if I want to graph y equal to the x squared minus 3, all right? So y equal to x squared minus 3, and I would say here, okay? I'm always starting with the parent functions here, right? So the parent functions here, okay, so this is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. A lot of people like this section also because of graphing, I guess. Okay, so I'm going to draw the parent function because that's not my final function. So I'm not going to use a solid line. I'm going to use the dot line. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, right? Just like we did before. So this is my parent functions here. Okay, so this one is 1, 1. This is negative 1, 1, right? This is 0, 0. This point here is 2, 4. And this one here is negative 2, 4 here. Okay, now look here, right? Now look here. This is what? Minus 3. That means I'm going to shift down 3s here. So let's see what is our final graph looks like. My final graph, okay. This point is going to shift down 3. This is 0, 0. So I'm going to shift down 3. It's here, right? This is 1, 1. So I'm going to shift down 3. So it's 1, 2, 3. So we shift to here. This one is negative 1, 1. So shift 3. 1, 2, 3. We shift to here, right? So this is a 2, 4 because the x is not moving, right? So it's y shift down 3. So 4 going to shift to down to where? So 2 to 1s, right? Negative 2 to 1s here. So now this is my final functions here. Right? So that's what we said, the shift. All right, so now let's take a look at the one more, become a little bit more complicated, not too complicated. We're going to gradually and increase that. Okay, so now if I want to do the graph, y equal to the x minus 3 squared plus 2. Okay. All right, so this one's here. Let's see here. Let's start with, okay, start with functions, right? Okay, so now this is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, so still do the parent point, right? 0, 0. So it's this one, 1, 1, negative 1, 1, 2, 4, 1, 2, 3, 4, 2, 4, 1, 2, 2, 4 here, right? So this is my parent functions here. So put the dotted lines here, put the dotted lines here. Okay. Okay, now I'm going to take care of the parentheses first, right? Parentheses here. Okay, so what is my parentheses here? Okay, so my parentheses here is minus 3 here, x minus 3. So I shift to the right 3 units. So this is a shift to the right, right? 3 units. Okay, so see here, that means x shift, y not change. So 0, 0, shift to the right. 0, 0, shift to this point. This is 1, 1. So x shift to the 3, 1, 2, 3. So this point shift to here. This one's here, negative 1, 1. So shift 3, 1, 2, 3. So this point shift to here, right? So now this is 2, 4, right? Shift 3. So it's 1, 2, 3. So this point shift to here. This point is 1, 2, 3. This point shift to here. And so this one's here, this is still is not my final function. So I'm still have a dotted lines here, right? Okay. Now the last one's here, I am going, go what? So add 2. So what means add 2 is up 2, right? So that means everything need to shift up 2 here. Okay, so now let's take a look. Okay, so 0, 0, shift to here, up 2. 1, this one's here, up 2. 1, 2, this point shift up to here. This point 1, 2, this point shift up to here. Then this point 4, up to 1, 2 is here. This point 1, 2 is here, right? So now this is my final functions here. Now I draw such terrible, I draw a solid line, but you see that is quadratic, right? Okay, so that's what we mean. Your shifting and your transformation is a lot easier than just do the graphs here. Okay, so now let's take a look at the other ones here. I just like to do more examples so you will see that. Okay, let's take a look at root functions here. Root function, in fact, is pretty easy. Okay, so this is the examples, right? So I have a y equal to the x minus 2 plus 2. All right. Okay, so now let's take a look here. Okay, so for the root functions, we know we have what this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2. Okay, we know the key point here is 0, 0, right? Okay, so 0, 0 is here. And we know the key point here is 1, 1, right? So 1, 1 is here. Then we have 4 2s, right? Those are the few points can help us, 4 2s here. Right, so this is a parent function, so I do a dot. Okay, then I do what is inside the square roots. Okay, so take a look here. This is a -2. So that means what? Shift to the right 2 units. Okay, so this 0, 0 shift to here. 1, 1, 2 units, 1, 2. This one shift to here. 4, 2, so shift 2 units, 1, 2, shift to here. But this is not the final yet, right? This is not the final yet because I'm only do the inside root. So here, this is my, still is a dot line. So now, finally, I'm going to have +2s here. That means everything need to go up 2. Okay, so start from the purple one, 1, 2, this point go up to here. This is 1, 1, right? I need to shift up to 1, 2, so this go up here. This is a 6, 2, so here I need to shift up 2, so it's 1, 2, so it's here. Now this is the final, so I use the dotted lines here. That's what I mean here, right? That's what is my function. Okay, so the finale here, let's do a pretty complicated one here. Okay. See, we can do that. So this is y is equal to -x plus 1 square plus 2. Okay, so let's do this one. And hopefully we can do that. Okay, so here. Okay, and okay, hope that my lines are straight. Okay, so now I have a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so quadratic. 0, 0, 1, 1. -1, 1. 2, 4. -2, 4. Right? Those are the points can guide us. Okay, let's start it one more time. 0, 0 is here. 1, 1 is here. -1, 1 is here. 2, 4. 1, 2, 3, 4. 4 is here. Okay, -2, 4 is here. Okay, so this is a parent function. So I use the dotted line because that's not my final functions here. All right. Okay, so we do, okay, so the next things here, I'm going to color, right? So the x plus 1. X plus 1, that means what? That means shift to where? Shift left, right? Okay, so shift left 1. Okay, so that means this point going to shift to here. This point going to shift to here. This point going to shift to here. Then this point are going to shift to here. Then this point are going to shift to here, right? Okay, so this is just did one function, so I still have a dotted line. Oh. Okay, so that means, okay, so here, I hate to do those drawings, just very, okay, so here. Okay, so still the dotted lines, right? So that's the yellow. Okay, now we do another function. What is this? It's negative. So what is negative? That's what is here. The negative means what? Reflecting over x-axis, right? That means I'm going to flip over to the x-axis. Okay, 0, 0, no place to flip over, so still here. This one's here is 1, I flip over to here. This one's here is 1, I flip over to -1. And this one's here is 4, I flip over to the -4's here. This one's here. This one's here, I flip to the -4, right? Okay, so now this one, I still not finished, so still is a dotted lines here. All right. Okay, so my last one's here. I finally I finished almost done here, so it's a +2. So where is the +2? That means the purple one, I need to go up 2. So this one go up 2, so here, 1, 2, go back here. This point 1, 2, go back to here, right? This point 1, 2, go back to here. This is -4, 1, 2, go back to where? 1, 2, go back to here. This one, 1, 2, go back to here. Now this is my final product. I can draw that in a solid lines here, solid curve. So this is my final functions, right? So this is a -x + 1 to the square plus 2. Okay, so we used almost all the transformations, right? Okay, so that's what is the transformations. So we talk about in this chapter, and we're going to use this again later sections here, because when we try to do the graph, we will use it again, right? Okay, so that's it for the section 10.2. Our next topic will be section 10.3. We're going to talk about a polynomial. We can't believe we only have 2 more sections. 10.3, 10.4, 10.5. I think that's it, right? And that will be the semester. I can't believe time goes so fast. Okay, I hope you guys all have a good time and be safe, right? Of course, keep up with the work. Do not, the kind of piling up, right? Okay, so just do every time the same day, finish the video, finish the classwork. Okay, nice talk to you again. So I guess we'll talk to each other next time. Okay, bye.